Okay, so next, actually, we have to have a part 3, but I skipped that for a while. So I just go to the an application of the motion in space in space first. Before then, after that, I will back to the part 3, which is about the unit tangent and unit normal vector and so on. Okay. Okay. So here, the topic is focusing on the application about the motion in space, where we have the velocity, we have speed, we have acceleration. So using the vector function, as we know that when we have the vector function in terms of t, it's just like we have a particle movement, right? The particle path. Then you can evaluate the velocity of that, the moving of that subject or particle. So using the vector function, the velocity v, the vector v, it is given by the derivatives of the vector r. Okay. So here we can see that this is called velocity vector. So velocity vector is equal to tangent vector. So in part 3, you have the derivatives of the vector function r. So that is called tangent vector. So in this case, because the formula is the same, but the way we elaborate the physical meaning of the form is different. I mean, formula is the same, but the way we interpret the problem is different. So if you're talking about the motion in space, so dr over dt is the velocity. Okay, but other than motion in space, so we have a tangent vector. So we can also determine the direction of that motion, where the formula is the unit vector. So this is unit vector of the velocity vector. This is the formula of unit vector. As we know that any vector, when any vectors, there must be the unit vector of that particular vector. So in this case, you have the velocity vector. So what is the unit vector of the velocity vector? So v over its magnitude. Okay, now we go to the speed. You can also compute the speed of the particle moving, where you just use the velocity vector, and you find the magnitude. So that is speed. Okay, the velocity as we know, that is r prime t, and find the magnitude. Okay, and ds over dt. So the ds over dt, so you will learn later for this. So to compute the speed, you can also use the ds over dt, because we know that speed is not a vector function. It's just a regular, it is a value. So that's why ds here is not vector. Okay, so the s is something that I will explain later. So then you find the derivative, so that is also speed. Or we can say that so we can say that the speed is the rate of change of the distance respect to time. So we can say that s is just like a distance or arc length. Okay, distance, the rate of change. So speed is the rate of change of distance respect to time. How about the acceleration? When you have the velocity, to get the acceleration, you have to differentiate the velocity, and you will get acceleration. So velocity vector, the derivatives of the velocity vector respect to t will give you acceleration, or as we know that v is from the derivative of r respect to t, so it's just like the second order derivatives of the vector r. So this is the graphical representation of the velocity vector, the vector r. This is position vector r, and this is the tangent vector, unit tangent vector. So unit tangent vector you will learn after we done the motion in space. So I will once we get there, so I will be back to this graph. Okay. Okay, it just like now I want to explain the graphical meaning. Okay, the physical meaning of the what is mean by the velocity vector and the r. Okay, so we are talking about the motion in space. So the space mean 3D. You have x, you have y, you have z. So you have the particle moving. Okay, so let's say this is your path. Okay, that is your path. So let's say you choose a single point over here. Okay, so what is the position vector there? So this is the vector r. So this in general. So now on this point, you must have the some specific value of t, right? So now you label the position vector for this particular point. So let's say you want to provide the labeling of the position vector r for specific t. Let's say I put when t is equal to a, so that is your position vector. So you can evaluate evaluate the speed at this point. You can evaluate the speed, the velocity, and also the acceleration. Okay, so as you can see that at the beginning here, look at the velocity. So the r over dt is just like a tangent vector. Tangent, you know what, when you have y is the function of x, so you draw the graph arbitrarily, okay, whatever graph that you have, and then you can evaluate the tangent or the slope. I would say the slope, the tangent of the curve for the specific t. For example, you want to evaluate the slope on this point, at this point. So what you have to do is, so you can say that you can provide the tangent line, which is the tangent, or the slope. So how can you get that? You just differentiate. You have the dy over dx. So this is called tangent or slope. But now we relate with the vector function. So just now we're talking about velocity. Velocity is from the tangent vector. Okay, because we're talking about vector, so the tangent vector. So the tangent vector here is just like you have a tangent line, that one, and then that is your vector, a velocity vector or specific t. So your t is a at a. Okay, so you can evaluate the velocity and also the speed at this point when t is equal to a. Okay, and then because of we haven't discussed yet about the unit tangent vector. So this is just tangent vector, which is given by velocity. Okay, but unit tangent vector is given by capital T. Okay, the expression in terms of t. So this is called as unit tangent. So the unit tangent is always as stated here, is the same direction as the v, but the length of the tangent vector, the unit tangent vector, is always one, a bit shorter, which is maybe only this. Okay, they have the same direction but different magnitude, because the unit tangent here is a unit vector, where the magnitude is always equal to 1, which is you can see that they have the same direction as vector, the velocity vector, but for unit tangent they have a smaller length. I mean a bit shorter because the magnitude is always equal to 1. Okay, so that is the how can we relate the vector v and the unit tangent vector. Okay, so next example, we are going to solve this particular example.